When an equation of a line is missing one of the variables, sometimes it can be a little confusing because it looks like there's not enough information there. But if we take a deep breath and remember that the equation is describing all of the points that have that characteristic, then it's easy to sketch a picture and then even visually picture, mentally picture what it's describing. So for example, the equation y equals -2 doesn't really look like the equation of a line. But what it's saying is that we should plot all of the points whose y-coordinate is -2. So if I just think about all of the points whose y-coordinate is -2, they'll all fall along here. And if you're not sure, just pick a couple of points like -3, -2, and 3, -2, and 5, -2, and just plot them, and you'll see that what you get is a horizontal line where all the y-coordinates are -2. On the other hand, if you had an equation that only has an x in it, like x equals 3, that's describing all of the points on the grid whose x-coordinate is 3. And so here are the points where the x-coordinate is 3. And if you picture 3 or 4 of them, then you'll realize that that is a vertical line. So even if one of the variables is missing, we can still draw a picture of the line, and it'll either be a horizontal or vertical line. The final topic here is thinking about what happens when lines intersect. So let's draw a picture of the graphs of the two equations that are written here. And I'll do that by, for example, for f of x, I'll draw a dot at where I know the y-intercept is. And then I will, oops, that's not where it is. Sorry, where the y-intercept is. The y-intercept here is at 0, -3 for the f of x function. And then I will use the fact that the slope is 2/3, which means that every time I go over 3, I need to go up 2. So over 3, up 2, over 3, up 2. I'm running off the screen. But these will be my points. So it'll go something like this. That'll be, something like that will be the line 2/3 x minus 3. So that's what my graph of f of x looks like. On the other hand, the g of x line will have its y-intercept at 0, 1, and has slope, every time I go over 3, I'll go down 4. So a slope of -4/3 means my rise over run is to go down 4 for every 3 I go over. So I'll count 1, 2, 3 over, 1, 2, 3, 4 down. So I would have this slope. Let's see if I can hit that correctly. It's pretty good. And so you can see, when you draw these two lines, that there's an intersection point right about there. And so when we're looking for the point of intersection, we want to know the coordinates of that point. So here's how we could do it algebraically. We could eyeball it graphically, but you'd have to have a lot of confidence in my drawing to do that. But algebraically, what I would do is take the two equations and set them equal to each other. So in other words, I'm trying to find the x so that f of x equals g of x. The reasoning for that is that this green circled point that this green point that I've circled has the same xy coordinate on the red line as it does on the blue line. So I'm trying to find a pair xy that's on both lines. So that means the y coordinate should be the same and the x coordinate should be the same. So the formulas are the formulas for the y-coordinates. So I'm setting them equal to each other to say that the two y-coordinates are equal. And then I'll figure out what the x has to be to make that happen, and that'll be the common x-coordinate. My strategy for solving equations that have fractions in them is to multiply. So I would multiply by 3 as my first step in order to clear the fractions. Because in this case, the fractions have a common denominator already. It's not the worst case thing in the world to not do that. You could just add and subtract to both sides and it would seem fine. But I'll be consistent and just do my step, multiply by 3 on both sides first. So if I multiply everything in the first equation by 3, I'll have that. If I multiply everything in the second equation by 3, I'll have this. Now I've cleared the fractions, so I can add 4x to both sides, and I can add 9 to both sides, and I'll have the equation 6x equals 12. And so from that, I will determine that x is 2, and that looks pretty spot on. My drawing was actually way better than I thought. So my x-coordinate will be 2 in this point of intersection. the y-coordinate I get will be the y-coordinate from the red line or the y-coordinate from the blue line. Those should be the same. So it makes sense to actually check both of those just to make sure they are the same. So if you plug 2 in for x into the formula for f of x, you'll have 4/3 minus 3. And I'm just going to write down the answer. You can check this, but I'm not going to take the space to do it here. So f of 2 will be minus 5/3. I'm getting that by plugging 2 in for x in this formula, and then just using my rules for fractions. Similarly, g of 2, I'm putting 2 in for x in this equation, and I will also get minus 5/3. So the equation here, the coordinates of this point, the x-coordinate is 2, the y-coordinate is negative 5/3. And so what that means is, from the point of view of the functions, is that is the input where the functions have the same output. That's what the point of intersection means.